Hi, everybody. Welcome. This is the videos that are quite a bit delayed. Apologies for that for the week two of videos. So, as a reminder, your homework one was posted and it looks at relational algebra. Some of us may be familiar with it, but these videos are more so on overarching database designs. I'm just going to go through these slides and add a bit more as we're going through them too. But again, this is just to give you a general taste of this information in kind of two parts. So previously in our first week, we talked about DBMS systems, and essentially it's a collection of data around a particular enterprise. This data can be highly valuable, large, and accessed by different applications as well. And again, some of these applications could be something like social security systems, where we're looking at how much information is on a person, or Amazon when they store recommendations for people. So all of these are things that are impacting our lives, especially as we're using technology more and more. And some examples of these, definitely what we've seen already. For instance, in enterprise sales, as I said earlier, Amazon has some aspects of this. Now, database systems are also have very sensitive information, such as in banking. So information, loans, transactions, and stuff like that can be stored in databases as well. Okay. Great. And again, there's also web-based services that are there too. But I think a good resource that we could use here as well is for our own university. So when we're looking at university database examples, we can kind of think about what type of data is going to be managed and what tasks should be done over the data. And these two questions here are also useful for not just your project, but if you're interested in doing full stack web development or some type of database programming in your future, or you're communicating with maybe a smaller company that you can try to work with. You got to ask these two questions of what type of data are we looking at, and then what do we want to do with that data as well, right? Because it's better to start with a better large scale operations that is flexible to changes that are needed rather than one that's more tight. So some examples of this idea for universities in particular is student data, instructor, and classes. For instance, an application could add new students, instructors, and courses. You can kind of think of your Catalyst account itself when you're adding these big database system. And then, of course, registering students for courses, making sure that you have a system in place that could check for your prereqs and stuff like that, and then being able to get your GPA out. Great. A little bit of this slides talked about the early days of file systems. So because I'm a bit younger than this, I actually don't have deep experience with this. But essentially, in file systems, they used to have databases built right on top of it. But that was an issue. For instance, here, if a student has two majors, they would have two different like accounts essentially inside of there, and that just causes a whole bunch of issues, especially integrity problems, where something is buried inside of the code rather than being stated there. Okay. One more things of these file systems here is inconsistent state with partial updates, which is very bad, especially if you're running in real time with multiple users. So another issue here is concurrent access. So you can kind of think of this as people inside of a group chat together at the same time, or even like in multiplayer games that we have. If we have these issues of data not being processed and accessed at the same time, it causes inconsistencies, which also causes issues for users, but also some security problems too. Cool. So when we're talking about why we're looking at this database system in general, is we want to take a look at the abstract view of our data that we have. So there's going to be two ideas here: data model, which is your structure of the database, and a data abstraction. So essentially, you could have a very complex user inside of your database. For instance, your students. At the start of it, you might just have a student ID, but inside of that data of student ID, you might have a first name, last name, email address, parents' information about your high school, and that can kind of go way more complex than something that is just a student ID for it there. And the reason we want to do this data abstraction is that it simplifies the user's interaction with the system. So abstraction is something you might have heard of before in your previous classes. Another way to think of abstraction is if you think about like food through drive-throughs, you kind of just see the menu, and then when you order, the food comes out, but you don't really know everything that's going on inside of there. So that just kind of abstracts a lot of the complexity from your system too. Great. So some of these are talked about inside of our project design information, but data models include your relational model. This also includes the entity relationship, which is what we're going to touch on a bit today, and then an object-based data model. So this is going to be more familiar to object-oriented. I know in data structures, we did a bit of object orientation with C, and so also this semi-structured data model that we have. Cool. So relational model in general is going to be a collection of tables that represent both data and the relationships among that data. So all the data is going to be stored in various tables, and most widely used data model and the vast majority of database systems is shown here. So the instructor table shows a relational model of instructors here. So you have your columns, and you can kind of think of this as an Excel sheet as well with what we're familiar with, where each column has an attribute that you can see here. If you think of this as an object-oriented as well, this has attributes of self.id, self.name, and then you have rows. So this is the instance of each of these individual data pieces. So what is the relational model here is that this is the instructor table or the instructor relationship here, right? So an instructor has an ID, name, department name, and a salary, and that's the instructor's attributes, and this is actually instances of your instructor. Okay. This is a little bit rougher looking, but this is just more for it as well. You could have the instructor table further, maybe a department table as well. So same idea. And if you're familiar with Excel or if you've seen these types of spreadsheets before, this might be something a bit familiar too. But again, this is what a relational database looks like here. Okay. So what we want to look at next is we have these two separate relational databases, but how do we actually get them connected, right? So this is where our entity relationship model comes into play, and this is going to visualize a collection of entities and relationships that we have. So an entity, in this case, our instructor, a thing or object in a domain that is distinguishable from other objects. And this entity is described by a set of attributes. And again, these attributes are what we saw earlier, ID, name, department name. Okay. Now, this is going to be described by a set of attributes that we have too. Oh, I'm sorry, said earlier, but we have a relationship, which is where there's an association among several entities to something else. So this is going to be diagram in a diagram by an ER relationship here, right? So you can see an instructor is a member of a department here. So one thing that we kind of want to start thinking about is how do we know which one is unique when we're looking at these areas here? Well, let's go back to our names here. And this is again thinking about what your data, what you want to abstract in your data and make easier to use. So what type of thing inside of our attributes is going to be unique, right? So our name, these are all pretty unique names in all of these areas here, but they might not be very unique. You might have another person with the name Gold enter your database, right? So what happens when we're trying to use Gold to see who's a member of a department? We're not too sure which one we'll get back, right? So the point of this saying is that the ID, because it's underlined it here, is going to be the identification. It doesn't necessarily always have to be ID, but this is going to identify which type of data point you're going to be looking at. Okay. Same idea here for your department name. All of these department names are going to be pretty unique there, but we can see here that some departments are in the same building. So if we had the building underlined, we might not know which department to actually look at. So again, this comes from practice, but just being aware of what your main point of contact is inside of these tables is useful. Okay, cool. So the relational model is usually flat. It has these atomic values that we usually see. So earlier we had these IDs or these integers here, but there's also this idea of object relational data models. So this is going to extend this flat association just between ID and department name by including some type of object orientation, and that's going to have more added data types. So this allows us to have some more complex types, including non-atomic values, which include nested relations or strings as well. And this also helps preserve relational foundations that we looked at earlier. Okay. So again, main point of this idea here is this is a brief look at your entity relationship model. Just be aware of how these people work together, and this idea that an entity is a member of has a relationship with another department. Excuse me, another table that we have. Cool. So there's two types of semi-structured data. Some of us might be familiar with JSON more than XML, but again, XML was used back in the day with www consortium, and JSON is more JavaScript object notation. So this is usually worked with web apps as well. But again, XML is used quite a bit as quite a bit too as ways to exchange data. So XML looks a bit like HTML if we're familiar with that as well. We have kind of these open and close brackets, very similar if you open a purchase order, excuse me, you close a purchase order. And then, oops, then we have the middle there as well, just to show us information. So we can see we have an identifier. The purchaser is this person here. Supplier comes from here and so forth. JSON is a little bit organized slightly differently. We have an ID. This is similar to what we saw earlier. This is my ID. Then we have our name. So this is our attributes or our columns that we have. And this is the information that will go into the row. Okay, cool. So we talked about abstraction a bit earlier today about what to hide from individuals here. So there's the physical level of abstraction, and this is going to be describing how a record is stored. So essentially, do we store it using the ID or something else? There's a logical level, which is going to describe what data is stored in the database and the relationships among the data. So it's not just what the data is, but also how they are looking together. So the type instructor is going to be a record with this information here, and that's what we'll store. And then we have a view level, which is where the details of these data types are kind of hidden, such as salary or maybe ID that we have. And then we just can show to people, maybe on the front end of an application, what the data is going on with there. Great. So we could see here the overall view of how this process works is that we describe how a piece of data is stored. We describe what and the relationship between that data is, and then we finally show to our database system what we'll see in the front end. Okay, cool. So when we're actually taking a look at this this view of this data, we can look at the schema, which is our overall design of the database. So that's going to be your huge relationship there. You have logical schema, which is where this is going to talk about how we actually go about this database. So the example that we have here is there's sets of customers and accounts in a bank, and then how do we have a relationship between the customer and those banks there? So there's two analogies we can use here. So this is analogous to the type of information of a variable in a program. So this might be a string or an int. You can kind of think of it that way. We have a physical schema, which is the overall physical structure of the database, which is what we saw earlier here at the physical level. And then we have an instance, so the actual content of the database at a particular point in time. So again, if you're running an application for 5 days, your instance of that database is, or the instance of the schema is going to be how much users you have and how much information is stored in there. In this sense, similar to what we have, if I declare a variable to be an integer, there'll be a logical one. If I declare it to be an integer of value 5, that's the instance of that variable. Okay, so the general idea here with all these vocabularies, not to memorize all these, but to just be aware that your database is going to transform over time, but to have these kind of schemas in mind to make sure you remember what you want it to do. Okay. So there's a few independencies that we want to look at as well. So the ability to modify the physical schema, which is going to be what the structure is, without changing the logical schema. So this is going to be the interfaces between various levels of components, and they want to be well defined so that if we want to add something into there, so that if we want to modify something, it doesn't influence everything else in there. So for instance, if I wanted to go back to sorry, it's a bit far back. If I wanted to remove a salary here, I want to make sure that my physical schema doesn't get completely thrown out the window, right? And we'll be okay here because ID is related to department. So that's the only way we have it. So I can kind of go right ahead and modify the physical structure there. The same idea applies to our logical data independence. So this allows us to modify the logic behind our schema without changing the application. So again, add new information. So earlier we saw that children was added into our JSON. So maybe we want to put that into our database too. Okay, cool. So DDL or data definition language is another type of language where it's a notation for defining database schema. And again, if you're unfamiliar with this type of syntax so far, don't worry too much. Once we get into actual coding, we'll go through this too. But I want you to uh, remember that this is non-procedural language where it's more declarative. So what you're trying to say is what you want to get and not how you're going to get it. We'll look at that a bit later, but essentially what we're trying to say here is create a table that is called instructor and then give it these attributes. Now here, these might be a little unfamiliar, but you can kind of think of these as strings if you want to too. So this is a character of 5. Some people say char or car. Whatever you prefer. I'm just going to say character. This is a variable character as well. And this 20 in here tells you how many number or how many things you could put inside of it. So I could only have an ID of at most 5 characters inside of it. The salary is going to be numeric, and this gives me 8 floating points and then 2 decimals after it there. So 82. Okay. So this is going to create a template sort of data dictionary, and this is going to contain metadata that we have as well. So some aspects of database schema, constraints there. So this primary key is what we looked at earlier. Remember we saw the underline. So the ID uniquely identifies instructors, excuse me. And again, you want your primary key to be something that won't be easily repeated. So you don't want to put primary key as name because maybe some people might have the same name. Okay. Authorization as well. So you might be familiar with some of this, but row level access or admin access as well. So you probably don't want everyone to access instructor data, but you might want everyone to be able to access their names somewhere. Cool. So there's also data manipulation language, DML, and these are usually built into just one like programming language like SQL here. But this is going to be a type of language that queries the data that we have, known as query language. We have a procedural DML. So this is where a user specifies what data are needed and how to get those data. And then declarative. A user specifies what data are needed without specifying how to get those data. So essentially, the difference between here is one of these might be from table instructor, uh, select all instructors with salary above 200K. And the declarative would just be from data instructor, give me everything. It's a little bit of a butcher of the example here, but the main thing is that in procedural, we tell it how to get that data. Excuse me. And in declarative, we don't need to specify how to get the data. That's the main thing there. So the portion of a DML that involves information retrieval is called the query language. So you might hear this quite a bit. We're going to learn how to query some languages here. That's kind of what this portion is doing. Cool. So this is something that we've heard of quite a bit, SQL or structured query language. And this is a declarative. Again, declarative means that we don't specify on how to get that data back to us language here. So find the name of the instructor with ID 2222. So select name. So select the attribute from my table instructor and select it from the table instructor where the attribute ID is equal to this value. Find the ID in the building of instructors in a physics department. Select instructor ID department.building. So this is the cool thing about SQL as well, is that you can kind of do, after you put these commas, you can do multiple queries on different tables. And we got to say from where we want the instructor to be, the ID in the building to be selected from. And remember that these kind of line up with each other. So you don't want to swap these around, or you don't want to say department twice. And then where you have the instructor, that department name is equal to this one here, and department name is equal to physics. Okay. So again, we're not really saying what to do with that data after it, but we're just saying, get me this data, right? And this is where our declarative or non-procedural language is helpful. And again, excuse me, this is used quite a bit in nearly all database systems here. Cool. So just a bit more information about these as well is that the applications that we usually look at are going to be interacting with databases here. There's also this idea of a host language where we have a kind of higher language with embedded SQL queries that access the data. So essentially, even though you're building an application, you wouldn't build it using SQL. SQL is usually going to be embedded within your application to do that database manipulation. Okay. Cool. So following this one, we're going to take a look at the database design idea. But I was hoping to just give this video as a brief overview of what type of coding you're going to be seeing. Again, we didn't do anything crazy here. I just wanted to kind of get your head turning about what type of what SQL is and how we're going to be looking at it. And later on, we'll do the actual coding. Great, thank you.